Previously on 8th grade algebra from home.
And then we solve those quadratic equations by setting them equal to 0. And then we learn how to factor in order to solve them. We'll use the inverse operation. I'm going to start to factor that. I factored out a 4. We're going to be factoring in order to solve quadratic equations. After we finish factoring this, factor what's on the left. We can factor that. We can factor the other side. Form solving equations by factoring. We factor it, we factor it and solve for what we factor equal to 0. Then we set to factoring.
Okay, so today we're using square roots to find the solution to quadratic equations. Or in other words, today we are not factoring. Here's how we're going to get there. First, we're going to talk about fancy looking math. Then we're going to get into what square roots are, talk about square roots as inverse operations, the meaning of two special symbols. We're going to go to a key point, and then we're going to work through 3 examples together. Finally, I'm going to share the steps for success with problems like this, and then you'll be on your own, trying to work through several problems on your own. Do you know who this person is? This is Dr. Katherine Johnson. She's a famous mathematician who wrote the code that actually helped send the first astronauts to the moon. It's pretty impressive. Now, you've probably seen some scenes in movies, maybe Hidden Figures, where she was profiled, maybe another movie, where you'll see math written on a chalkboard, and it just looks insanely complicated. And you've probably thought to yourself, I don't know if I could actually understand any of that math. Well, today, you're going to get a glimpse into some of the math that happens to look really complicated to some people that's right within your reach. We're going to do that by starting to examine a scenario having to do with square roots. So here's a quick scenario. This might seem a little too easy, but for what value of x is this true? X squared equals 0. Go ahead, you know it. That's right. X is equal to 0 because 0 times itself, or 0 squared, gets what's on the right, which is 0. What about this one? X squared equals 9. Easy, right? If you got an answer of 3, then you're right. But you're also not right. Because although you're right that 3 squared, meaning 3 times 3 equals 9, that's not the full story. There's another solution that also works. Did you find it? Here it is. Negative 3 also works because when you multiply negative 3 by itself, negative 3 times negative 3 is also equal to positive 9. So here we have 2 solutions. We have the solution that x is equal to 3, and we have the solution that x is equal to negative 3. And as we find today, oftentimes when we have squared terms that we're solving for, we're going to find 2 solutions. If you don't believe me, here's another way to look at it, which is that we can subtract 9 from both sides using inverse operations. And I know I promised we're not factoring today, but you could. If you did, you would get a difference of 2 squares, x plus 3 times x minus 3 equals 0, which is true when x is negative 3 for the left term or positive 3 for the right term. You can see that on the graph. It crosses here at 3 and negative 3. All right, let's talk a little bit about inverse operations. If we have an equation like this, we can isolate the x term by using the inverse of minus 3, meaning we could add 3 to the left and the right. When we do, we would get x equals 7 plus 3, or x equals 10. Here's another inverse operation. When we have 4x equals 8, we have x times 4 on the left. The inverse of times 4 is divided by 4. So we divide both sides by 4, and we get x equals 8 over 4, which is equal to 2. Well, we can do it here. X squared minus 9. So first let's get rid of the minus 9 by adding 9 to both sides. When we do that, we're going to get x squared equals 9. But then the inverse of squaring something is actually the square root. So we just take the square root of both sides, and we get x equals, and then there's that weird symbol, plus or minus square root of 9. All right, so now let's talk about some of these strange terms and symbols that we're seeing. So in the chat, or in your Desmos classroom activity, I want you to write your description of what this number means. What does the square root of 5 mean? Well, it actually has 2 definitions, 2 ways of thinking about it, and they both might surprise you. So they both involve the word positive. 1, it is the positive number that when you multiply it by itself, you get 5. 2 is it's the positive answer to the question x squared equals 5. Now you might be wondering, what is that? Is that number 25? It's just called the square root of 5. That's its only real name. It's somewhere between 2 and 3, closer to 2, because 2 squared would be 4, 3 square root would be 9. So it's somewhere between there. Right? That's what the square root of 5 is. Now I could show you a decimal approximation, 2 point blah blah blah, but that's not the point here. Now the square root of 9 goes by another name. You would call it 3, because 3 is the number that when you multiply by itself, you get 9. So now let's talk about what this plus or minus term means. Where did that come from? Well, as we saw earlier, when you have something squared equals 9, if we took the square root of both sides, we get 3, but the reality is 3 and negative 3 worked. Remember? So when we had 3 and negative 3, the way of saying that is plus or minus 3. Brings us to our first key point. When we have the equation in the form x squared equals n, we can take the square root of both sides to find the value of x. That's the inverse operation. But to account for the fact that x could have been positive or negative, we need to say that x now equals plus or minus the square root of n. So that plus or minus is going to tell us that we have 2 solutions. This is where it starts getting good, trust me. We're going to go through 3 examples together, and you'll see where all these fancy symbols come in and how we can find complex-looking solutions to real problems. For example, if we have x squared equals 16, we can take the square root of both sides and get the square root of x squared equals the square root of 16. Or, to put it more simply, x is equal to the square root of 16, plus or minus. Now that means we have 2 solutions. Do you know what the square root of 16 is? What number, when you multiply it by itself, do you get 16? Well, there are 2 of them, 4 and negative 4, which you could write as plus or minus 4, or you could write x is equal to plus 4 and minus 4, or positive 4 and negative 4. Here's another example. If we have x squared equals 8, think to yourself, do you already know the number that when you multiply by itself, you get 8? You might be thinking 4, but 4 multiplied by itself is 16, not 8. So we take the square root of both sides. You can predict what we're going to get. Did you say plus or minus? You should have. X is equal to plus or minus the square root of 8. Now, you're going to learn in a couple years another way to simplify this, but for now, we can just continue to call it plus or minus square root of 8. It doesn't simplify to an integer. There's no integer that when you multiply by itself, you get 8. So this is actually our answer. It's 2 answers, positive square root of 8 and negative square root of 8. So you might be wondering at this point, this seems fairly simple. Why didn't you tell us that earlier? I mean, factoring is hard. Why have we been spending all our time learning the really hard way? And taking square roots is way easier. We just write plus or minus square root of whatever we had. Well, it turns out it only works when we have something squared equals a number. Like something on the left squared, x squared, or maybe x plus 1 squared in parentheses. Something squared equals a number. For example, if we had x squared minus 3x plus 9 equals 0, we could try to use inverse operations. So we'd have subtract 9 from both sides, get x squared plus 10x equals negative 9. But then we're a little bit stuck because we don't have something squared on the left. Now tomorrow, we're going to see something we can do to get something squared on the left. But for now, we're kind of stuck, so we can't really use this method. Right? We don't know what to do. Sometimes there are more steps. Let's take a look at this one. So if we want to isolate the x squared term, let's use inverse operations. First, let's add 1 to both sides. Now we have 4x squared equals 81. And now to get x squared by itself, let's divide both sides by 4. So now we have x squared equals 81 over 4. We can use the inverse of the square function to do square root on both sides. Square root of x squared equals square root of 81 over 4, except we need that plus or minus. So x is equal to 9 over 2 and negative 9 over 2. Now you might be wondering, if you don't remember your square root rules, can you just do that? And the answer is yes. Yes, you can. I'll prove it to you. Do 9 over 2 times 9 over 2. You know how to multiply fractions straight across the top, straight across the bottom, and you'll get 81 over 4. Okay. If you don't remember the rules, that's fine. Sometimes we forget rules. Just check it with a number that you know. But sometimes it gets really fancy. Say we have 5 times quantity x plus 1 squared equals 25. Now, if you're like me, you know that 5 times 5 is 25, so you're thinking, oh, this is going to be easy. That term just needs to be 5. And, well, you're right that it needs to be 5, but you're not right about it being easy. Check this out. So let's use inverse operations, divide both sides by 5. Now we're left with x plus 1 quantity squared equals 5. Still seems kind of easy until you realize that when you take the square root of both sides, you're going to get the square root of 5 on the right. Don't believe me? Try plugging in numbers for x to see if you can get x plus 1 squared equal to 5. Not as easy as you thought, huh? Me neither. So what do? Well, we take the square root of both sides, as you see in the upper right here. And then we're left with x plus 1 is equal to plus or minus the square root of 5. I want to pause there to make sure that that step makes sense to you. Now that we have that, we have x plus 1 is equal to the square root of 5, or x plus 1 is equal to the square root of negative 5. You'll see we split that plus or minus square root of 5 into two different equations. From then, it's relatively simple. On the left, following the green arrow, if we subtract 1 from both sides, then we have negative 1 plus square root of 5, or square root of 5 minus 1. On the right, x plus 1 equals negative square root of 5. We subtract 1 from both sides, and we get negative 1 minus the square root of 5. We can combine those two solutions again to write it as x equals negative 1 plus or minus the square root of 5. Now, you've probably never written something that looked quite that fancy. That's like something you would see on one of those college chalkboards. Now you're going to know where it comes from. It comes from taking the square root to solve a quadratic equation. So let's review what we did. 1, we used inverse operations to get something squared equals some number. In this case, we divided both sides by 5 to get quantity x plus 1 squared equals 5. Then we took the square root of both sides. Square root of x plus 1 squared equals square root of 5. We made sure to write it as plus or minus because we knew there were going to be two solutions, the positive and the negative version, that when we squared it, we would get 5. So we wrote two expressions. Something equals the positive square root of something, and something equals the negative square root. Finally, we wrote those as two expressions and simplified and solved each equation as needed. We did that by isolating the x in the left expression and the right expression. If you want to be super fancy, you could rewrite it as that x equals negative 1 plus or minus the square root of 5. I like to write it like that. You can write it either way. Now, I know that that ramped up pretty fast, and it got pretty complex pretty quickly, which is why it's great that you're going to have the rest of today's class to practice this. We're also going to continue to practice this skill over the course of the next several days. So if you're not quite getting it yet, I wouldn't worry too much. Just try to get a little bit farther than where you are now. All right, thanks for watching. Have a great day. See you tomorrow. Bye.